In this introductory tutorial, you will learn how to set up and analyze an EDEM simulation model that uses a conveyor belt to transport material to a hopper. First, start by setting the required units for the simulation. Next, define the bulk and equipment materials. After the bulk material and interaction properties have been defined, the particle shapes for the bulk material need to be created. Add a MultiSphere particle. For this tutorial, we are going to import a CAD template of a rock and fit 4 spheres to the template shape. Under Mesh Control Type, leave all the settings as the default values. Change the Display Templates option to visualize the imported template. Input the physical radius and positions to define the particle shape.
La ubicación de cada esfera de la partícula base está definida en el tutorial.
You can highlight the spheres in the view settings to be able to distinguish the location of each sphere. Add another sphere to the particle shape by right-clicking the Particle Spheres table. In the Rock Particle Properties section, tick the Imported Template option and click Calculate Properties button. Please note that an automated way to generate spheres to fill a template is outlined in Appendix 1 of this tutorial. Next, set the size distribution of the bulk material. For this simulation, we'll select User Defined and add the following distribution parameters. The next step is to add the equipment material properties. Input the bulk and equipment materials interaction. The next step is to import the conveyor geometry. Set the units to millimeters and leave all the mesh settings as the default values. Rename each section appropriately. Next, add a conveyor translation motion. This motion will last for 2 seconds with the following acceleration value. Right-click on the belt geometry and add a second conveyor motion. The second motion is a constant velocity of 2 meters per second starting at 3 seconds. The display vector tick box shows the direction of the chosen motion. Next, create the particle factory geometry. The polygon created defines the area where the particles are generated. Set the type to virtual, since the plate is not a physical part of the machinery. Set the position and size of the factory. Set the factory initial parameters. In this model, the rock particles are created at a rate of 50 kilograms per second. Initialize the particles with a velocity in the z direction to improve particle creation. Set the domain of the simulation, and ensure that the auto-update from geometry box is checked. Save your model and move to the EDEM simulator. Set the time step, the simulation time and the data write-out frequency. When using the CPU solver, define the cell size, which is recommended to be around 2 to 3 times the smallest particle radius in the simulation. Choose either CPU solver or GPU CUDA solver. Once the simulation is finished, move to the EDEM analyst to post-process the results. The display section in the analyst tree is used to configure how the different elements in your model appear. Uncheck the Display Particle Factory, so it is not visible in the viewer window. Next, represent the rock particles using a particle template. To do this, select Template from the Representation option. Set the representation back to default before continuing. Next, color the particles according to their mass. Unselect the Auto Update option and set the minimum value to 0 kg and the maximum value to 0.8 kg. Color the belt geometry by velocity. There are different options for visualization you can explore. Play through the simulation to see how the belt velocity changes with time. This data can also be exported. Next, create selections that will allow you to monitor any element passing through a particular area, or track specific elements as they move within the domain. Set the properties for the newly created grid bin group. Right-click on Setup Selections one more time to create a second grid bin group and name it. Set the properties of the bin group as follows. Define selection group queries to compare the total mass of particles passing through the first bin group with the number passing through the second bin group created. Select the conveyor group under Setup Selections, and select the Queries Edit button. Select Mass, set type to rock particle, and query type to total. Select the Total over Time option. The query is displayed in the list at the bottom of the dialog. Repeat the previous steps to define an identical query for the hopper group. Select the conveyor group again, then in the Representation section, click the Display Options Edit button. Tick the on-screen query checkbox to display the mass in the viewer. Repeat the same steps for the hopper group. Click the play button to view the results in real time. As playback continues through the time steps, the bin group data is collected and displayed. Finally, create an export configuration. Define a query to export bin group data. Tick the output averages, maximums, minimums, and totals in columns checkbox. Uncheck all, then set the range to start at about 6.3 seconds. Click on the particle element in the list, then select mass. Click the Export button to export the data to the predefined file. You can view the exported file using an external application, such as a spreadsheet, and review the data.